We are going on with organic chemistry 1 revision, having cleared that part of the syllabus. Okay, so we are dealing with question number 1. We are using KLB 3. You remember that? Yes. The questions which are at the back of that particular topic. Crude oil is the main source of organic compounds such as hydrocarbons. The hydrocarbons in the crude oil have to be separated. Name 4 important hydrocarbons obtained from crude oil. So this question requires us to indicate the fractions which are present in crude oil. So which are the fractions which are present? We can be having 1, kerosene. Kerosene is the same as paraffin. Okay, paraffin. Another fraction is diesel. Another one is gasoline. Another one, you can be having bitumen. Okay. Bitumen is the same as tarmac or tar. Bitumen is the same as tar. We also have uses for each. What is the use of paraffin, diesel, gasoline, and tar? Now, kerosene or paraffin is used as jet fuel. So the function of this one is jet fuel. Okay, or fuel for aeroplanes. Diesel is fuel for diesel engines. Okay, so diesel is fuel for diesel engines. Okay, we have seen some vehicles usually use diesel, especially those which are carrying heavy load, transportation of heavy load. So most of the lorries that we have on our roads usually uses what? Diesel, because diesel produces far much more energy as compared to what? To petrol. Gasoline. What's the use of gasoline? It is? What is it? So gasoline is the same as petrol. Very good. Okay. That is the same as petrol. Therefore, this is fuel in petrol engines. Fuel in petrol engines. Good. And then lastly, we have bitumen, which is the same as tar. What's the role of bitumen or tar? Construction of roads. Very good. So this one you can see road surfacing. Okay. For construction of roads. Very good. Let's move on. What do you understand by the following terms? Catalytic cracking and thermal cracking. So for the case of catalytic cracking, let's start with thermal cracking. For thermal cracking, what happens? A long chain alkane is broken down to short chain alkenes, and hydrogen in the presence of high temperature. Okay? So this one you can say is breaking of long chain alkane to what? To short chain alkane. Okay. Alkenes and who? And hydrogen gas. So the long chain alkane is 1. Okay? The alkane which is produced is only 1. But the alkenes are more than 1. Which are the product? Hydrogen gas. Are you seeing that? So the long chain alkane is only 1 molecule. But when it is broken, what is produced? Short chain alkane, which is only what? 1. And then alkenes are more than 1. And then what you have again? Hydrogen. Okay? Now, this occurs at high temperature. At what? At high temperature. At high temperature. So the temperature used in thermal cracking is high. Okay? Thermal means high temperature. What about the second one? Catalytic cracking. That one now, we break a long chain alkane to short chain alkane, alkenes, and hydrogen at relatively low temperature, relatively low. It doesn't mean very low. Are we together? Relatively low temperature in the presence of what? A catalyst. Okay? So this one is even a longer statement, so we have said this one is breaking long chain alkane to what? The short chain alkane, alkenes, hydrogen gas. This is hydrogen gas. At what? At relatively low temperature. At relatively low temperature. Okay. In presence of a catalyst. So if you are keen enough, everything that is present in thermal cracking is present also in catalytic cracking. Okay? The only difference is that the temperature is relatively low. Okay?
Yes.
And then, what do you use? A catalyst must be there for the process to occur. Is that okay?
Yes.
The catalyst is the difference with the other. Temperature is also slightly different. The other one is high temperature, the other one is relatively low temperature. Now, let's go to 4. Explain why an organic compound with the formula C3H6 burns with more salty flame than C3H8. This one conforms to the general formula CnH2n. So this is an alkene. So this is propene. Okay? This is which alkene? Propene. Are you together? And this one, C3H8, conforms to the general formula CnH2n plus 2. So this is an alkane. Are we together? And this one is an alkane with 3 carbon atoms. Therefore, this is propane. Okay? Propane. There are so many chemical tests to differentiate between alkenes and alkanes. But here, we are being asked why this one is producing a lot of soot, while the other one is not producing a lot of soot. So this one is unsaturated. Propene is unsaturated, while propane is saturated. Okay? When you say this one is unsaturated, we mean it has a carbon-carbon double bond. What about the other one? It doesn't have a carbon-carbon double bond, but instead it has single covalent bonds only. Are we clear? So you come here and say propene is unsaturated. What do you mean? It has carbon-carbon double bond. Are we together? It has a carbon-carbon double bond. What about propane? While propane is saturated. When you say propane is saturated, what do you mean? It has single covalent bonds only. Are we together? So it has only this carbon, single covalent bonds only, like this. We do not have a double bond anywhere in its structure. Are we together? Now we move to the next question. Butane and bromine reacts as shown. So this is butane reacting with bromine, and those are the products. Name the type of reaction taking place in the equation above. Now the type of reaction taking place here is known as substitution reaction. Reaction between alkane, this is alkane, okay, and this is what? Halogen or bromine. You can say this is bromine. Okay? Now the type of reaction is what? Substitution reaction. Substitution. As we were learning, we said alkanes undergo substitution reaction, but alkenes and alkynes undergo addition reactions. We can pause a bit and laugh. I want us to look at question number 5A. Butane and bromine reacts as shown. So this is our butane. 1, 2, 3, 4. This is butane. This is butane. Now butane is reacting with bromine. You can do it like this. You can say this is bromine. So you put here Br and then Br. Now what happens? What happens is this. Bromine will come here like that, and then hydrogen will go here like this. Are you seeing that? That is what will happen. Now what products will be produced? Now the products will be produced will be as follows. We have 1, 2, 3, 4. The first one, hydrogen, 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 and then this one, hydrogen, hydrogen. Here, hydrogen, hydrogen, and here, hydrogen, hydrogen. I need to be very keen. What has happened? Bromine has gone to the other side. Is that okay? So here we write bromine. Bromine was of which color? Black. So here you write bromine here to show that bromine has shifted from here up to this other side. Plus what? Now this is plus the other product, which is what? Hydrogen, which is blue. It has gone to the other side, followed by who? Bromine. Okay? Like that. Can you see what has happened? What has happened? Bromine has taken the position of hydrogen, and hydrogen has taken the position of bromine. So what has happened? Substitution. So this is butane, this is bromine gas or bromine liquid, like that. Now the product here is made it as bromobutane. This is bromobutane, our product, and this one is what? Hydrogen bromine. Hydrogen bromine. We are done with that. We now go to question number 5B. I hope you have seen how the substitution has taken place. Yes. B. State the condition under which the above reactions takes place. Now, this reaction will not take place in the dark. What is required? Sunlight. Very good. So the condition required here is sunlight, and sunlight is also referred to as UV light. That's the other name. Okay. A hydrocarbon tube was found to decolorize potassium manganate cell. So when an hydrocarbon is in a position of decolorizing potassium manganate 7, then it is either an alkene or an alkyne. Are we together?
Yes.
That is either alkene or alkyne. In other words, it is unsaturated. Unsaturated. It has a carbon-carbon double bond or a carbon-carbon triple bond. Okay, when 2 moles of Q are bound, so we are having an hydrocarbon which is CH. We don't know how many hydrogens are present. We don't know how many how many carbons are present. We don't know the number of carbon atoms and hydrogen atoms. So we have been told when 2 moles, so this one is 2 moles of an hydrocarbon which you don't know, but we know it is either alkene or alkyne. Okay, this is a gas. It's reacting with what? It's completely burnt. So burning, you are reacting with what?
Oxygen.
Oxygen gas. Okay. 6 moles of carbon 4 oxide. So now the product produced here is 6 CO2. 6 moles of carbon 4 oxide. Okay. And 6 moles of water were formed. So here it is plus 6 moles of water, which is a liquid or a gas, because there is much heat being produced when it is being burnt. Now you are being asked, write the structural formula of Q. To be able to write the structural formula of Q, this is our Q. We balance the equation, we get the value of X and Y and Y. The equation is already balanced, but what is X and what is Y? Now, 2 times X to know the number of carbon atoms. 2 times X, 2X. Very good. 2X is equals to, how many carbons here? 6 times 1? 6. So X is equals to 6 divided by 2, which is equals to 3. 3. So you already know that X is equals to 6. Is equals to 3. Good. Then we move to the next one. We want to know what's the value of what? Y. 2 times Y. 2Y. Very good. 2Y is equals to, let's look at hydrogen here. 6 times 2, 12. 6 times 2,
12.
12. Very good. So you divide by 2. Divide by 2. So Y is equals to, by 2, 1, by 2, 6. Y is equals to 6. Are you seeing that? Now our compound Q is CXHY. So you come here, we write CXHY. Now substitute X and Y. X is equals to 3. So the formula is what? C3. Because X is equals to 3. HY. Y is equals to 6. So H6. And that is the molecular formula. Hope you have seen. Are we together?
Yes.
Good. Now let's go to the next. Name the homologous series to which Q belongs. So this Q belongs to which homologous series? You look at the homologous series that we have. CN H2N plus 2 belongs to which organic compounds?
Alkanes.
This one belongs to alkane?
Alkane.
Alkanes. So here, this is alkanes. Okay? And then we have CnH2n belongs to which organic compounds? Alkenes. Okay? Belongs to alkenes. Then finally, CnH2n we less 2. This one belongs to which organic compounds?
Alkynes.
Alkynes. Are you seeing that? Now let's see. Our organic compound is C3H6. Does it conform to the first series, whereby n is equals to 3?
No.
Is it C3H2n? 2 times 3?
6.
6. Plus 2? 8. Is it C3H8?
No.
No. Remember, n is equals to 3? 3. So it is not conforming to this. So that one is not qualified. Using there you are testing. N is equals to 3. See there? From the formula there. C3H. 2 times 3? C3H. 2 times 3? 6. Is it conforming?
Yes.
Yes. So this one is correct. Okay. C3H2M. C3H2 times 3, 6.
Six.
6 minus 2, 4.
Four.
Is it C3H4?
No.
No. It's not conforming to this. So to which of Madagascar series does it conform?
Alkanes.
Alkenes.
Alkenes.
Alkenes. Like this. So the right answer is that alkenes. So you have seen the way we have tested until you have got the answer. Are we together?
Yes.
Very good. Name one industrial source of Q. One industrial source of which one?
Q.
Q. Where do you get Q? It is an alkene. See there? Look at here. Catalytic cracking, thermal cracking. What is thermal cracking? Breaking of long chain alkanes with alkane, long chain alkane, to short chain alkane, and then alkenes. Are you seeing that? And then alkenes. And hydrogen gas? Yes. So one industrial source of alkenes is
Breaking.
cracking. Are we together?
Yes.
So we write here cracking. Cracking. Of what? Of long chain alkanes. Very good. So that is what we have. So